So in the last class, we saw that. In the last class, we saw that in factors affecting. So just wait a second. Just wait a second. Factors affecting solubility of gas in liquid, solubility of gas in liquids. Okay. So we were talking about pressure, right? We were talking about the third factor, that is pressure. Now, I want all of you to see what happens when we have a gas inside a liquid. Wait, my just wait a second. I am just cleaning my spectacles. They look kind of dirty. Can't see very clearly. Yeah, better. How are you, Danya, by the way?
I'm fine, sir. How are you?
I'm also good. I'm also good. Okay. So we have a beaker of some of the stain, and in here we have water. In here we have water. We have added some solute particles. Please remember that these solute particles are what? These are gaseous solute particles. Okay, these are gaseous solute particles, and obviously some of the solute particles that is in the solution, they will be escaping out of the solution, right? And there will be some gaseous molecules here just above the solution, right? And they will be coming inside, colliding with the surface of the solution and getting dissolved in the solution, right? All of you can imagine this, yes or no? Please tell me.
Yes.
Right?
Yes, sir.
Now, this phase here, this is also solute. The solute that is present just above the solution in gaseous phase is known as vapor phase. It's known as vapor phase. And the one which is present inside the solution, which is dissolved in the solution, the gas molecule, they are known as in aqueous phase. I'm just imagining now, assuming that this solvent is water. Okay, so I can write aqueous phase. AQUEOUS, right? Aqueous phase. Okay, now I can say that if the concentration of solute is high, right? That means we have large amount of solute particles inside the solution. Then can I say that the rate of escaping out will also be high? Yes or no? Please tell me. If we have a lot of, okay, fine. Now you have understood that. That means there will be a large amount of molecule also in the vapor phase, correct? Right? All of these are gas molecules. They will be also in large amount in the vapor phase. Is that right? Yes or no? Please tell me.
Yes.
Yes. Now, since all of these gases, these vapor phase solute particles, these are gases. That means by the gas equation, ideal gas equation, PV is equal to nRT, है ना? And if you have a large amount of number of moles, then the pressure will also be high, right? So the pressure, the concentration of solute is high, then the pressure is high. Is that clear? Yes or no? Please tell me. The pressure will be high because we have a large amount of gas molecules. If we have large amount of gas molecules, they will be moving very randomly and applying pressure in all the walls of the container. Correct hai? Yes or no? Please tell me.
Okay, sir.
Yes, sir.
Right. Now we can write a relationship. We can write a relationship that pressure, the pressure of what? The partial pressure of solute particles in vapor phase, right? Pressure of what? The vapor phase particles, hai na? Of what? Solute particles only. So the pressure of the partial pressure of gas in vapor phase, it is directly proportional to the concentration of solute in solution. Okay. Now, in order to get any one of the concentration, so chemists, they have used and they have seen that it is perfectly, like it is aligning with mole fraction. Okay, chi b. Now, in order to remove this proportionality sign, we need to put a constant, that is k, into chi b, and this constant is known as Henry's constant, since this relationship was found by or discovered by Henry. This relationship was discovered by Henry, and hence this is known as kh. It is known as Henry's constant. चलिए, यहाँ तक क्लियर है सबको? Yes or no? Please tell me.
Yes. Yes, sir.
Please write this down ना. Please write this down. Everything is new from here ना. कुछ भी तो कल का नहीं है यहाँ से, तो सब कुछ लिखिए. Then we'll write what is Henry's law. We'll do some questions. We will talk about what is kh, and hopefully we'll also do some application. Okay. So please write this down. Let me know when you're done. Okay, only Zad is done, waiting for others. Dania, Alina, Hanifa. Okay, great. So let the next topic, that is Henry's law. The next topic, that is Henry's law. Please write with me. Please write with me. Okay. Partial pressure gas in the vapor phase. Gas in the vapor phase is directly proportional to the mole fraction of gas in the solution. Okay, so this is Henry's law, and mathematically speaking, pressure, it is equal to kh into chi b. Okay, kh into chi b. So this P is what? P in this equation is the partial pressure of gas in vapor phase. Partial pressure of gas in vapor phase. What is this chi b?
Mole fraction.
It is the mole fraction.
Sorry.
Mole fraction. Yeah. Somebody said something.
Sir, mole fraction of solute.
Solute. In solution. है ना, और kh तो आपका हेनरीज कांस्टेंट है ही. Please write this down and leave at least half a page. Hamza, am I audible?
Yes, sir.
Okay, leave at least half a page and try to be on time. Huh? Waiting for Dania, Hamza, and Hanifa. Just waiting for Hamza now. Okay, great. So you guys can lower your hand, and now we'll talk about the Henry's constant kh. We'll talk about the Henry's constant kh. So here we have Henry's constant kh. Okay. So first thing is, what will be its units? Unit of kh. Okay. So we have seen that pressure is equal to kh into chi b, right? Kh into chi b. So kh will be equal to pressure upon chi b, right? Now we know that this chi b, it is what? Unitless. right? And that is why the unit of KH will be is equal to whatever the unit for pressure is there, right? So the units for pressure will be ATM. So this can be also the unit for KH or bar or torr, है ना? So all of these can be the units of KH. Okay, the units of pressure will also be the unit of KH. Is this clear? Yes or no? Please tell me.
Yes.
Okay. Second thing is that will KH be same for each and every gas or it will be different? So KH is going to be different for each and every gases. That means it is a function of nature of gas. It means O2 will have a different value for KH, H2 will have a different value for KH, N2 will have a different value for KH. So the next point that you will write is KH is a function of nature of gas. That is, it is different. That is, it is different for different gases. ऐसे लिख लीजिए its value is different. ठीक है, its value is different for different gases. Okay. Third point, we have already seen that KH is equal to pressure into pressure upon chi V, right? Now, if I hold the pressure to be constant, then I can say that KH is inversely proportional to chi V. Yes or no? Please tell me. Is the third point clear? Don't
Yes.
write now. Please tell me yes or no. Okay. What is chi B? Chi B is nothing but the concentration of solute in solution, right? Concentration of solute in solution. That means this concentration of solute in solution also means what? Solubility. The amount of solute in solution, it is also known as what? Solubility, right? Yes or no?
Yes.
It means that KH will be directly proportional to solubility or inversely proportional to solubility.
So
Tell me.
inverse.
Inversely proportional to solubility, है ना? So you can write this. KH is inversely proportional to chi V. That is the solubility here, है ना? And we can also write if KH is higher, KH is high, solubility is low. Solubility is low. Is that clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now, third point is done. Listen to the last point, fourth point, and then we will be done with the characteristic or the properties of KH. So we are learning about, please remember, we are learning about what the gas in liquid. We are learning about gas in liquid. So all of you will tell me, don't write anything. All of you will tell me what is the effect of temperature. If I increase the temperature, what happens to the solubility?
So decreases.
Solubility decreases. Okay, very good. Now let us look at the above statement and tell me what will be the value of KH here then. If the solubility is low, KH will be
High.
high, right? Now look at this and tell me what is the relationship between KH and temperature. KH is directly proportional to temperature, right? KH is also directly proportional to temperature. ठीक है? Now with this you will write one question. ठीक है? Should I scroll up? या लिख लिया सबने यहाँ तक? Third point तक लिख लिया है सबने?
Yes.
Okay. Aquatic animals are more comfortable in cold water than in warm water. Why? चलिए. Write till the question. Raise your hand when you're done. Then we'll discuss this question. Okay. Waiting for Dania and Hamza. Okay, great. Now, this question of aquatic animals is not a very direct question, है ना? ये हमको क्यों पता रहेगा कि उनको ठंडे पानी में क्यों अच्छा लगता है, गर्म पानी में क्यों नहीं, है ना? वार्म वाटर में क्यों नहीं अच्छा लगता है, right? But the real question is that they're asking about the solubility of O2. ठीक है? They're asking about the solubility of O2. So you tell me, where will the aquatic animals be more comfortable if you where you have more O2 or less O2?
Sir,
Tell
more.
me. Okay,
More.
more O2. Okay. So if you have more O2, that means if you have more O2, that means the temperature should be low or high.
Sir, low.
Tell me. If you want more O2, then the temperature should be
Low.
right? Temperature high. Then we have this is right. Temperature should be low. If the temperature is low, the water will be cold water, right? Yes or no?
Yes.
Yeah. So how to write this? This is the you have learned it. You can explain it, but how to write this answer? So in this answer, you will relate this to KH. We'll say that since KH is directly proportional to temperature and KH is inversely proportional to chi b. Okay, KH is inversely proportional to chi b. Then you can say that solubility of a gas is inversely proportional to low temperature. Therefore, more O2 is dissolved in cold water making it more comfortable. ठीक है? Waiting for Dania, Hamza, and Hanifa. Okay. Good. So everyone got this answer? Yes or no?
Yes.
Why they are more
Yes, sir.
comfortable? Yes. Okay. Now let us do one numerical. Then we will look at the applications of Henry's law. Then please write this down. Okay, you don't need to raise your hand. You don't need to raise your hand. Okay. So if N2 gas is bubbled through water at 293 Kelvin, how many millimoles of N2 gas would dissolve in 1 liter of water? Assume that N2 exerts a partial pressure of 0.987 bar and the KH of N2 at 293 Kelvin is 76.48 kilobar. 76.48 kilobar. Okay. So before doing this question, I want to explain you guys a few things. Okay. Whenever we want to get the numeric value of any physical quantity, है ना, we want to get the numeric value, numbers में आपको कुछ value चाहिए होंगे किसी physical property का, है ना, then you have two methods. Okay, so in order to the methods to get a value, numeric value, there are always two methods. You can listen to this very carefully. You don't need to write this. लेकिन इसको ना mentally पीछे आपके back of the head, this should be there in your mind. Okay, so you have two methods in order to get the value of anything. That value can either be measured or it can be calculated. Okay, and there are different requirements for both the things. If you want to measure something, then you must have a tool. That means you should have some kind of instrument that is going to measure the value. There are some things which are called, now these measured things, these are mostly simple, not very complex, mostly simple. And the calculated values and the values which are calculated, it should have, first of all, if you're going to calculate something, it should be having some kind of formula. Okay, and we should have the value of simple properties. Now, the best example for this is if you want to find the volume of a cube. If you want to find the volume of a cube, okay, tell me what is the tool you are going to use? Is there any instrument that can measure the volume of a cube? Tell me yes or no. Dania, Alina, Hamza, Hanifa, Zaid.
Yes, sir.
There is, okay. What is that tool called?
Vernier caliper.
Vernier caliper.
Sorry.
वर्नियर कैलिपर से वॉल्यूम मेजर होता है, फिजिक्स वाले सर आपको उठा के पटक देंगे.
No, sir.
Vernier caliper is used to measure very small length, right?
Yes, sir.
है ना, एक तरह का कॉम्प्लिकेटेड क्या है वो, स्केल ही तो है, इट इज नथिंग एल्स, रूलर है वो, राइट, है ना. सो सी, वी नीड अ, दैट इज वॉल्यूम के लिए, फॉर एग्जांपल फॉर क्यूब यू नीड सम फार्मूला, वॉल्यूम इज इक्वल टू ए क्यूब. अब देखिए, लाइक इट इज सो beautiful that you are calculating something complex and then you need the value of a simple thing, that is length here, है ना. लेंथ ब्रेड्थ और हाइट का आपको क्या चाहिए? You just need the value of length, breadth and height, ph, and this is just you are measuring distance. ठीक है, you are measuring distance. So in many of the cases you will see that, so this length can be now measured, right? This length can be now measured. This formula will be applied and I will get a complicated physical property, that is volume, जिसका कोई instrument नहीं होता है. Is that clear? Yes or no? Please tell me. Things that can be measured and things that can be calculated. Now, a good questioner will never ask you about the things that you can measure. अभी आप 11th 12th class में है ना, and after this is your college life. In college life you will be trained mostly for what? Mostly for whatever tools or whatever calculation or things you are going to do in the real life. ठीक है, जिसका कुछ ना कुछ या तो research में application है, or it has some application where it has some application in the product market. So you will be either learning about things that you can produce or things जहाँ पे research से development और किया जा सकता है. Okay, so in both the cases, now you should be trained to get the values which can only be calculated, है ना. अब देखिए कितनी बड़ी बेवकूफी होगी कि कोई क्वेश्चनर आपको बता दे कि वॉल्यूम क्या है ना, कोई क्वेश्चनर आपको क्या बता दे, वॉल्यूम क्या है, एंड देन आपसे पूछे कि व्हाट इज द एज लेंथ. ऑल्दो यू मस्ट नो दैट यू हैव डन दिस टाइप ऑफ क्वेश्चंस, यस और नो?
Yes.
है ना। लेकिन अब ये रियल लाइफ से जोड़ के देखिए तो बेवकूफी है ना, कि वॉल्यूम वॉल्यूम आप जब बता रहे हो हमें, तो हम एज लेंथ के लिए हम फॉर्मूला क्यों लगाए, क्यों ना हम एक रूलर लेके बस नाप लें, राइट। ये बेवजह की जो रिस्ट्रिक्शन है कि thinking that you will not have a ruler in order to measure the edge length, that is completely futile, है ना। so you will always, a good question will always ask you to calculate something which cannot be measured, है ना, which cannot be measured. Is that clear? Yes or no?
Yes.
ठीक है, so you can keep this mental framework in the back of your mind, ठीक है, in the back of your mind, and then think in terms. अब देखिए इसी सवाल को ले लेते हैं, जब भी हम लोगों ने लिखा है, I'm just clearing up this part. Okay, I just have to everyone is new here. Okay, now see, in this case what they have given, the pressure is given, yes or no, है ना। आप ये इमेजिन
Yes.
कीजिए दैट अगर आपको ऐसे कोई एक बॉटल लाके दे दिया है, राइट, and they have just said that we have here water, and in this water there is some nitrogen dissolved in it, है ना। अब ये तो नाइट्रोजन डिसॉल्व है, it is a closed container, you can't even open it because N2 is a gas, it will escape out, and they are asking what is the concentration here, what is the mole chi b, or what they're asking, or how many millimoles or how many moles of N2 is present. अब ये बताइए, will there be any instrument that is going to calculate this very complex thing directly, कि आपको बता दे कि इतने मोल से N2 में पानी में डाला आपने, बता दिया इतने मोल से N2 के,
No.
no,
sir.
right? But see, you have what you can do, you can apply a barometer or manometer here, जो आपको क्या बता देगा, यहाँ पे प्रेशर बता देगा, है ना, और वही प्रेशर दिया हुआ है आपको। प्रेशर कैन बी मेजर्ड, सो दैट इज व्हाई इट इज गिवन। करेक्ट है, यस और नो, प्लीज टेल मी। Pressure can be
Yes.
measured, and that is why it is given here. Okay, it is given here. So you can directly apply P, it is equal to KH into chi b. ठीक है, P is equal to KH into chi b. From there you will get the mole fraction, and after getting the mole fraction, we will be calculating the number of moles or millimoles of N2. ठीक है, so let me clear this up, and we will write pressure, it is equal to KH into chi b. Pressure, it is equal to KH into chi b, and chi b, it will be equal to the pressure upon KH. So what is pressure? Pressure is 0.987 bar. Divide by, please tell me, who will tell me? Alina, आप बताइए, what is the KH of N2? KH of N2?
KH, we are 293 है।
यही होता है जब आप लोग सिर्फ नंबर पढ़ते हैं, सेंटेंस पढ़िए ना पूरा, read the sentence, I want to hear.
If N2 gas is cooled through water at 293 Kelvin. Okay, the KH for N2 at 293 Kelvin is 76.48.
ठीक है, now next thing, you will try to focus on words, then on numbers, है ना। ये बेवकूफी की बात होती है, ये सब अच्छा यहाँ पे 293 है, यहाँ पे 1 है, यहाँ पे 0.987 है, यहाँ पे 293 है, यहाँ पे 76.48। अब इसी में मल्टीप्लिकेशन, डिवीजन, एडिशन लगा के 4 बेसिक मैथमेटिकल ऑपरेशन लगा के आंसर लिखा, ऐसे नहीं होता है, ठीक है। इट इज नॉट हाउ थिंग्स आर डन। फर्स्ट ऑफ ऑल सी क्या लिखा है, लेटर्स लिखते हैं सबसे पहले, राइट। यू हैव टू कंसंट्रेट एंड फोकस ऑन वर्ड्स फर्स्ट, एंड देन सी उसका क्या वैल्यू है, उसका क्या वैल्यू, उसका क्या वैल्यू, नॉट ऑन नंबर्स। स्टार्टिंग में नंबर्स तो नहीं। बताइए फिर से पढ़िए इस लाइन को। Yes, Alina, tell me. The KH for N2 gas, the KH for N2 at 293 Kelvin is
76.48 Kelvin bar.
हाँ, केल्विन का जो होता है दैट इज कैपिटल के, जो छोटा के होता है दैट रिप्रेजेंट्स किलो, ठीक है। किलो का, किलो मींस 1000, राइट।
Yes.
ये कितना हो जाएगा, 76.48 into 1000 bar, and bar will cancel out. Now this is also correct in terms of units because mole fraction will not have any units. So I can write 0.987 divided by 76480. 76480, right? Here we have decimal point. 3 आगे बढ़ा दिया हमने. Now you can write this as 0.987 को हटाइए. यहाँ पे लिख दीजिए 987 divided by 76480 into 10 to the power minus 3, है ना? We have replaced the 3 decimal point, that is why 10 to the power minus 3. Now, one approximation that we are going to do here is you will take this as 990 and you will take the below one as 7650. Okay, into 10 to the power minus 3, इसको हमेशा याद रखिएगा, and then you will get this as 99 upon 765 into 10 to the power minus 3. चलिए इसको solve कीजिए. Solve this. Let me know when you are done. Send the answer in chat for Kaibi. Correct that. लेकिन जैद टेल मी डेसिमल प्लेसेस के हिसाब से बताइए, ठीक नहीं लग रहा कुछ हमें.
let me-
0.129 होगा ना इस रुपये तो. 0.129 into 10 to the power minus 3. हाँ, correct. 0.129 into 10 to the power minus 3. That means you can write this as 1.29 into 10 to the power minus 5. Yes or no? Please tell me, all of you.
Okay, sir. Yes.
Okay. Now, chi B, we all know that it is equal to the number of moles of B divided by the number of moles of A plus number of moles of B. Now this value is equal to 1.29 into 10 to the power minus 5. है ना? इसमें they are asking the number of moles of the solute. Millimoles में they are asking the number of moles of solute. First of all, we have to find the number of moles of solvent, that is Na. Okay. So we have seen that how much water is present. Tell me. Gas is dissolved in 1 liter of water. So 1 liter of H2O is equal to 1 kg of H2O. Please remember this. This is the density. कितना था? 1 gram per ml, right? So 1 kg of H2O, that means 1000 gram of H2O. The number of moles of solvent will be equal to the mass of solvent, 1000 gram divided by 18 grams per mole. Grams and grams will cancel out each other, and please remember this value, that it will be equal to 55.56 moles. So the number of moles of water in 1 liter of water, number of moles of water in 1 liter of water is always equal to 55.56. Remember this value, it will be very helpful in the competitive examination. 55.56 moles. Okay. Now we have got this value. We will now put it here, that NB is equal, wait a second, chi B is equal to NB upon Na plus NB. This will be equal to how much? 1.29 into 10 to the power minus 5. अच्छा, अब ये बताइए, which will be smaller? Which will be smaller, the numerator or the denominator? कौन छोटा होगा? Tell me, guys. Which will be smaller? Look at this value here and then tell me. Achha, this value is very small or very large? 1.29 into 10 to the power minus 5. छोटा या बड़ा है?
Small.
Small, right?
Yes.
अब बताइए कि आपका न्यूमरेटर बड़ा होगा या डिनोमिनेटर, कौन बड़ा होगा? देखिए, इसको देखने के कई तरीके हैं. 10 to the power minus 5 को हम कैसे लिख सकते हैं? ऐसे लिख सकते हैं 1.29 upon 10 to the power 5. बताइए, ये सर नो?
Yes,
sir.
सही है ना? तो कौन बड़ा है बताइए, डिनोमिनेटर या न्यूमरेटर? इट्स वेरी लार्ज, राइट? बहुत बड़ा है कि नहीं है? Yes or no?
Yes,
Very
sir.
large, right? Very large. So you can write that NB will be very small. इतना हम बस ये कह सकते हैं कि NB is going to be very small. Here NB is very small. And NB is also what? It is very, very smaller than 55.56. And if it is very, very smaller than 55.56, then if I add a very small amount to some number, it is not going to affect it. If I add a very small number, for example, आपसे बोले कि 1000 में से you add 0.01 और उसके बाद फिर हमें वापस कर दो अपना मेरा पैसा. So it is negligible amount, right? So we can neglect it while calculation. So we can neglect it while calculation. It is not going to affect the answer. So we will write, but यहाँ पे नहीं, okay? NB upon 55.56, it will be equal to 1.29 into 10 to the power minus 5, and NB will be equal to 1.29 into 55.56 into 10 to the power minus 5. ठीक है? अच्छा, please tell me, is there anyone who has doubt कि ये NB को आपने क्यों नहीं neglect किया sir? You have only neglected the NB from the denominator, why not from the numerator? किसी को doubt है? No. Okay, fine. So please write this down. Send the answer in chat. What will be the value for NB? Is this clear? Yes or no? Please tell me. Okay. So you're getting a value. कितने लोगों ने भेजा? एक ही है, हनीफा ने भेजा है बस. Waiting for a few more answers. I think it is correct, Hanifa. Is that correct? Hanifa, are you using a calculator?
Sometimes.
No, I'm asking, are you using a calculator?
Not now.
Sorry?
Not now.
Not now. Okay. 71.64 something आ रहा है ना? 67. 6 into 10 to the power minus 5. That means we can write this as 0.716 into 10 to the power minus 3. All this will be in moles, right? You all know 10 to the power minus 3 is a number for milli. So this will be 0.716 millimoles.
Sir, where did the 10 raised to minus 3 go?
मिली हो गया ना वो. समझ में नहीं बात हमजा?
Yes, sir, understood.
हाँ, correct. चलिए. Write this down. Then we will look at the application of Henry's law. Zaid is done, Alina is done, waiting for Dania, Hamza and Hanifa. Hamza, let me know when you're done. Hamza, हो गया आपका? Raise your hand if you're done ना Hamza.
Yes, sir, I'm done.
हाँ तो बोलिएगा ना, कैसे पता चलेगा हमें you're done?
No, I actually raised hand, but it's not pressing. Okay, let me check.
The application of Henry's law. The first application, it is used in cold drinks or soft drinks. Okay, it is used in cold drinks, soft drinks, and any drink which has some soda in it. So they use Henry's law. How do they use Henry's law? So in soda water soft drinks, you have CO2, and you all see that all of them are like they're sealed back in a very high pressure. why are they sealed packed in a very high pressure? To increase the solubility of CO2. Because if I increase the pressure, the solubility of CO2 will increase. Then I can add more amount of CO2 inside the bottle. That is why all of them are sealed packed at very high pressure to increase the solubility of. Solubility means amount of carbon dioxide in the soft drink. Solubility of CO2 in soft drinks and soda water. The bottle is sealed under high pressure. Okay, it is sealed under high pressure. Is this clear, yes or no? चलिए इसको लिखिए. उसके बाद you have 2 more applications. उसके लिए आपको पहले कुछ समझना पड़ेगा. ठीक है, चलिए please write this down. Let me know when you are done. Okay, there is some question. D. हाँ Zad.
Sir, done.
अच्छा. What are you using, Zad? A laptop or a phone?
So a tab.
So you're using a tab. ठीक. नहीं, laptop में it is easy. Like you have a shortcut, Alt Y, and it raises your hand. Alt
Yes.
Y again, it lowers your hand. Okay. Hamza also done? Hamza,
No, sir, I'm writing.
writing, write fast.
Done.
अच्छा, एक बात बताइए, what do you think? If soft drinks are the one which has some soda in it, what will be hard drinks then?
They'll have more calcium or something like that.
Calcium. आपको strong बनाएंगे क्या calcium? Why
Sir,
calcium? No.
hard. Usually hard water is related
Hard
with.
water नहीं यार, तुम बिहारी हैं क्या आप? हाँ, hard water ले आए बिल्कुल. वो यहाँ पे दुकान में जो बेच रहा है उसको क्या पता hard water नहीं, that is not that. Soft water और hard water का वो सीन नहीं है यहाँ पे.
Oh, okay.
Not that. So hard drinks, they will be alcoholic drinks. Okay. Drinks की बात हो रही है ना. So they will be alcoholic. Soft drinks are those which do not have alcohol in it. Hard are those which have alcohol in it. Okay. So now moving on to the next application. Next application silly. We will first have to understand. See, this is C. Okay. This is C. And then you have, let us suppose you have mountains. Okay, you have mountains. Now there are 3 points that I will see here. First is sea level. That is the first point. This is sea level. Okay. Second point, which is at the top of mountain. Okay. And third point, under the sea. Okay. Third point is under the sea. Second point is you can see high altitude. Third point is we have deep sea, deep inside sea. So you will tell me where will be the pressure highest या फिर lowest बताइए. Where will be the pressure lowest? Lowest कहाँ पे होगा? 1, 2 या 3?
So sea level. 1.
1. और कोई? दानिया, अलीना, ये सनीफा?
Pressure will be low at high altitude.
It will be low at high altitude. ठीक है. So Zad ने कहा sea level, right?
Sorry. It will be high altitude, but I said sea level. It is wrong.
High altitude. Why high altitude? Tell me then. Why the pressure will be?
Atmospheric pressure decreases when you go high altitude. So
Why
low.
decreases? Why?
There will be less concentration of gases there.
हाँ, concentration की बात नहीं है, but it is like you will be experiencing less of atmosphere itself, है ना? अगर हम ऊपर की बात, like if I talk about the sea level, if you're standing at, let us suppose that this one is you, then the atmosphere that you're experiencing is all these atmosphere, right? The air that is present in all of these parts, you are experiencing the pressure due to all of these air particles. लेकिन जब आप high altitude में यहाँ पे हैं, then you just have a few, है ना? तो यहाँ पे आपको सारा का सारा atmosphere experience करने नहीं मिल रहा है. You're just experiencing less amount of air, right? And pressure, atmospheric pressure किसकी वजह से होता है? You have air particles. These are pulled down through gravity, right? These are pulled down through gravity, and that is where they are applying the pressure. That is one atmospheric pressure. है ना? So all of you can see that on deep sea level में क्या होगा? You will have the least, sorry, you will have the most, like the pressure will be highest at the deep sea level. So 2 followed by 1 followed by 3. Yes or no?
Yes.
उल्टा लिख दिया हमने ना, सॉरी. 2 का सबसे कम होगा, then 1 and then 3. अब please listen very carefully, don't write anything. So at 2 I can say that the pressure will be less than 1 atm. 3 में क्या होगा? Pressure will be more than 1 atm. Yes or no? At 1 it will be 1 atm, है ना? Normal atmospheric pressure is 1 atm. Now please listen very carefully. जब प्रेशर आपका 1 atm से कम है, when you have pressure that is less than 1 atm, then the solubility will be low or high? बताइए, solubility क्या हो जाएगी? लो हो जाएगी ना? Yes or no? Because it is less than normal. अरे बात समझ में आ रही है? Yes or no? Please
Yes,
tell
sir.
me.
Yes,
What about others? Alina, Hanifa, Dania,
yes, sir.
Yes, sir.
right?
Yes,
If pressure is less than 1 atm, the solubility will be low. If the pressure is less than 1 atm, solubility is low, then the things that should be getting dissolved in the blood will not get dissolved. Yes or no? Things
Yes.
that should get dissolved in blood will not get dissolved. Alina, Hanifa, Hamza, all clear? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now, which gas should be dissolved in the blood? Tell me.
O2.
Oxygen.
Oxygen. Very good. है ना? So what happens if I go to the higher altitude? The solubility of O2 decreases. Solubility of O2 decreases. ठीक है? अच्छा. अब जब pressure 1 atm से ज्यादा है, then the solubility will be high. सही है?
Yes.
Yes,
है ना?
sir.
That means the things that were not getting dissolved at 1 atm, if I increase the pressure and go to deep sea, those things will also get dissolved. Yes or no? Right?
Yes.
And the
Yes.
things that should not get dissolved, they're also now getting dissolved. If you talk about air, atmosphere, what is atmosphere? Atmosphere is mostly N2 plus O2. ठीक है? N2 plus O2, right? So इसको हम एक काम करते हैं. First of all, let us write the second point here about high altitude. Then we will look at the third point. ठीक है? So write with me the second point at higher altitudes. At higher altitudes, as the pressure is low, the solubility of O2 in blood decreases. And its concentration is low. Now what does this do? This causes dizziness and weakness. है ना? The condition is known as what? Anoxia. Okay, the condition is known as anoxia. There is also one more word, or altitude sickness. Please write this down. जल्दी लिखिए इसको. At higher altitude, as the pressure is low, the solubility of O2 in blood decreases, and its concentration is low. This causes dizziness and weakness. The condition is known as anoxia or altitude sickness. है ना, लोग पहाड़ों में जा रहे हैं, सोच रहे हैं कि उनको बहुत अच्छा ऑक्सीजन मिलेगा, साफ हवा मिलेगा, ऊपर के प्रेशर ही कम हो गया, कुछ ऑक्सीजन ही नहीं आ रहा उनके अंदर, वो मतलब ऑक्सीजन तो मिल रहा है लेकिन डिसॉल्व ही नहीं हो पा रहा बिकॉज ऑफ द प्रेशर, इट इज नॉट गेटिंग डिसॉल्व, वहां जाके उनको चक्कर आ रहे हैं, वीकनेस हो गया है, ठीक है। सो दिस इज ड्यू टू द लो प्रेशर, दिस इज ड्यू टू द लो प्रेशर। एवरीवन डन? यस और नो, प्लीज टेल मी।
Yes, sir.
Yes.
Okay, let us now look at the third point. Now the third point is inside the sea, है ना। तीसरा पॉइंट कहाँ पे? You are deep inside the sea. So there are deep sea divers, right? There are, don't write anything, there are deep sea divers, and obviously if you go inside the sea you will not have any oxygen, right? Not the water, so you have to take gas cylinders. To take gas cylinders, so जो initially gas cylinders बनते थे, so what they try to do, they try to mimic the biology, mimic the atmosphere. तो atmosphere में क्या होता है? Atmosphere में होता है mainly N2 और O2, है ना। आप ये assume कर सकते हैं that 70% is N2 and 30% approximately speaking is O2. Yes or no?
Yes.
Tell me. तो अब now in atmosphere we have N2 and O2, और उसी को हम लोग breathe कर रहे हैं, and we are only getting O2 dissolved in our blood. So the manufacturers were like, okay, let us mimic that, let me just copy what the nature has provided. That means we have N2 and O2 और इसी proportion में उन्होंने डाल दिया, right? N2 and O2 in the same 70-30 proportion. Now what happened? N2 जो 1 atmosphere पे है, N2 is not dissolved, N2 is not soluble, in blood, at 1 atmosphere. लेकिन as you go down, तो यहाँ पे तो एक तो आपका नॉर्मल है, राइट? यू आर एट सी लेवल, है ना। प्रेशर इज इक्वल टू 1 atm, है ना। N2 डिसॉल्वेबल नहीं है, तो यू हैव दिस ब्लड स्ट्रीम लाइक दिस, एंड द ब्लड स्ट्रीम इज एज इट इज, you just have blood in it and you have particles of oxygen. I'm not showing that, okay? And as you go down, as you go inside, what happens? The pressure increases, and you are now at deep sea. Now at deep sea, pressure is greater than 1 atm. अब यहाँ पे क्या हो रहा है? In the bloodstream you have some nitrogen also. अब nitrogen on its own it is not very bad because it is kind of inert only, ठीक है। तो यहाँ पे तो आपको कोई दिक्कत नहीं हो रही है because you have some nitrogen, okay, you have some nitrogen. लेकिन deep sea में तो नहीं रहना है, you also have to move out, right? When you come back, what will happen? The pressure will decrease. The pressure will decrease. Ab you are again at sea level, है ना। Again at sea level, pressure is again at 1 atm. अब ये जो नाइट्रोजन यहाँ पे डिसॉल्व हुआ था वो कहाँ जाएगा? It will escape out, right? Yes or no?
Yes.
Nitrogen will escape out because it is no more dissolved, it is no more soluble because pressure is decreased. So in the blood you have blood, that is fine. अब ये जो escape out हो चुका है उसकी वजह से क्या होगा? You will have some bubbles inside the blood, ठीक है। So these are bubbles, vacuum है in your blood. There are some vacuum particles in your blood vessels. So what will this cause? This causes blood restriction. This causes restriction in flow. Restriction in flow of blood. And if your blood is not flowing correctly, then oxygen will not be, सारे cells को oxygen नहीं मिल रहा है. If the cells are not getting oxygen, then what is going to happen? They are not burning the carbon that you have, and they are not producing any energy. If they are not producing any energy, then again you will feel some weakness. You can't think properly, and because blood has to go to your brain also. Brain में भी blood आपका time से नहीं पहुंचा तो आपको सोचने की भी क्षमता नहीं है वहां पे. Okay, so see, this is what happens. Sea level, है ना, sea level, and then you dive in, you come out, right? So when you dive in, what happens? Nitrogen gets dissolved, and when you come out, the nitrogen escapes and you form bubble, and that is why it causes restriction in the flow. Okay, it causes restriction in the flow. तो ये तो आपको अभी तो प्रॉब्लम ही है. Let us write about the problem first कि क्या होता है ना, क्या होता है, and after that we will see how all of them tackle this problem. So इसको लिखिएगा, ठीक है, थर्ड पॉइंट में इसको लिखिएगा, then you will understand what is happening, and after that you will write. When deep sea divers come back to the shore, the N2 escapes, forming bubbles in bloodstream. This leads to restriction in blood flow and causes weakness, etc. The condition is known as बेंड्स. ठीक है, कंडीशन को क्या कहते हैं? बेंड्स कहते हैं. राइट दिस डाउन. यहाँ पे ऐसे भी लिख सकते हैं आप, नाइट्रोजन डिसॉल्व्स, है ना, नाइट्रोजन escapes and these are bubbles. ठीक है, although इतना ना कोई आपको मतलब you will not see all of these things there, वो लिख के ही बताते हैं सब कुछ, but remember this कैसे होता है, and if you just write this point also in your examination that will be fine. ठीक है, यहाँ तक हो गया ना. So you know that the condition is known as bends. अब इसको deal कैसे करेंगे? So in order to deal with this, we have to add something which is even less soluble than N2. Yes or no? जो deep sea में भी dissolve ना हो पाए, right? Yes or no? Tell me.
Yes.
Which cannot be dissolved even in the deep sea, even at high pressure. And we have to keep the size of those gases very small, because if we keep the size of those gas particles which we are adding inside this gas cylinder, if they are very small, then even if they get dissolved, when they will escape out and form bubble, those bubble will be very small. उनको neglect किया जा सकता है, they will not be causing much problem. Yes or no? Tell me. है ना? तो दो चीजें हैं. First of all, the solubility should be very low, and the next condition is that the size should also be very low, because even if it get dissolved inside the deep sea at high pressure, when the deep sea divers they come out, and when the gas escapes and it is no more soluble, they will form bubbles which are very, very small and which are not going to affect the deep sea divers as much. है ना? Next, one more condition should be, it should be inert. है ना? It should not be reacting with the contents that is there in the blood. So one of the best candidate for this is helium. So I'll write this. Modern gas cylinders have the following composition. Approximately, please remember this is approx. They have 12% of helium. Okay, they have 56% of N2, and they have 32% of oxygen. So we have seen that we have decreased the amount of nitrogen to a very much extent and a large extent, and then helium को हमने increase किया, and oxygen is almost the same as what? एटमॉस्फेयर, है ना. Helium is added due to its very low solubility, small size, and what? Small size and inertness. ठीक है, and inertness. काफी है इतना लिखना. ठीक है, हीलियम, दिस इज नॉट ही, ये हीलियम है. Everything is clear till here, yes or no? Please tell me.
Yes, sir.
No doubt.
No, sir.
Okay. Write one more question. Write this question: 1 liter of water under nitrogen and under a nitrogen pressure 1 atm. That means the pressure that you have applied, that it is there, is 1 atm due to nitrogen. Dissolve 0.02 gram of nitrogen at 293 Kelvin. Calculate Henry's law. So what we have taken? We have taken 0.02 gram of nitrogen, and we have dissolved that inside water, sealed it, and then measured the pressure. The pressure was 1 atm. The pressure was 1 atm inside the chamber or the container.
So should we calculate the mole fraction also?
यहाँ पे तो वो करना ही पड़ेगा ना. You have to calculate the Henry's law, right?
Yeah.
So Henry's constant कैसे होगा? You have Henry's constant, then it is P is equal to Kh into chi b, है ना? If Kh into chi b is there and you have to calculate the Kh, this will be pressure upon chi b, है ना? You know the pressure,
Yes.
that is equal to 1 atm. Chi b नहीं पता है आपको, chi b कैसे आएगा? So you will write see 0.02 gram of nitrogen, it is dissolved in 1 liter of water, है ना? तो ऐसे लिखिए इसको. 0.02 gram of nitrogen means N2 होता है, ठीक है? नाइट्रोजन का नाइट्रोजन मत लिख दीजिएगा, नाइट्रोजन गैस है. So nitrogen gas is a compound that has the formula N2 mixed in 1 liter of water, है ना? 1 liter of H2O. So 0.02 gram of N2 से आपको क्या मिल जाएगा? You will get the number of moles of N2, that is number of moles of solute. 1 liter का मतलब क्या होता है? 1000 grams of H2O. यहाँ से आपको क्या मिल जाएगा? नंबर ऑफ मोल्स ऑफ E मिल जाएगा, दैट इज द सॉल्वेंट. और ये आपको पता होना चाहिए कितना होता है? 55.56. ठीक है, ये याद रख लीजिए. नंबर ऑफ मोल्स ऑफ वाटर इन 1 लीटर विल ऑलवेज बी 55.56. NB कितना हो जाएगा? गिवन मास अपॉन मोलर मास. व्हाट इज द गिवन मास? 0.02 grams. मोलर मास फॉर नाइट्रोजन जल्दी बताइए, कौन
Sir,
बताएगा?
14.
मार खाइएगा, यही दिक्कत है. नाइट्रोजन का होता है ना, 28 हो जाएगा ना.
Sir, 28.
28 होगा, ठीक है. यही गड़बड़ी करिएगा आप लोग. 28 grams per mole. Is this clear? Yes or no? Yes, Alina, Dania, Hanifa, is this clear?
Yes.
Okay, ठीक है.
Yes,
चलिए
sir.
तो फटाफट इसको कैलकुलेट कीजिए. NB, Na आपके पास है ही. Done, guys? Yes or no? Please tell me.
Yes.
Okay. So this will be equal to कितना आया बताइए? Somewhere around 7.15 कुछ के करीब आएगा है ना? 7.15 into 10 to
Yes.
the power -4, right?
Yes.
Okay. So now you need to calculate the chi b. Chi b is equal to number of moles of B upon number of moles of A plus number of moles of B. Number of moles of B is what? 55.56. No, number of moles of B is 7.15 into 10 to the power -4 divided by, and A is 55.56 plus. So this will be equal to how much? 0.00714 ना 715. ठीक है? Yes or no? एक दो एक और
Sir, एक
जीरो
बार
होगा, एक और जीरो होगा, 0.00715. ठीक है? अब बताइए 55.56 में इस नंबर को ऐड करने से कुछ चेंज होगा? Will there be any significant change? Yes
No,
or no?
sir.
Please tell me. No, right? We have 7.15 divided by 55.56 into 10 to the power -4. ठीक है? कैलकुलेट कीजिए कितना आ रहा है. इसको ऐसे लिख सकते हैं आप 715 डिवाइड बाय 55.56. ठीक है? 55.56 को 55.5 कर लीजिए तो आपको कैलकुलेशन में आसानी होगी. Here also you have 2 digits after decimal point. Here also you have 2 digits after the decimal point. It is like multiplying 100 on both sides. ठीक है? तो 100 both side कर दीजिएगा तो 715 and 555 आ जाएगा 10 to the power -4. चलिए इसको कैलकुलेट करके बताइए कितना आ रहा है.
So 0.13 10 raised to power -4 approximately.
Just 715 कितना, क्या कहा आपने, कितना आ रहा है?
So 0.13 10 raised to power -4.
ठीक है 0.13 आ जाएगा. सही है. 13 into 10 to the power -4. This is the chi b. Okay. अब this chi b यहाँ पे just plug in here KH केस में. हाँ, KH में प्रेशर कितना दिया हुआ? 1 atm. chi b कितना है आपके पास? 0.13 into 10 to the power -4. ये कितना हो जाएगा? 1/13 into 10 to the power -6 है ना. 1/13 into 10 to the power -6, right? Yes or no?
Yes.
ये हो जाएगा आपका 1/13 into 10 to the power -6. 1/13 कितना होगा बताइए? So 1/13 को आप लिख सकते हैं 100/13 into 10 to the power -4. ठीक है? 100 यहाँ पे कर लिया, ये 2 0 इधर आ गए हैं. ये 10 to the power नहीं सॉरी -6 का है ना, ये ऊपर जाकर +6 हो जाएगा, ये +4 हो जाएगा. ठीक है? तो 10 to the power -6 in the denominator will go above and it will become 10 to the power 6. 10 to the power 6 से 100 ले लिया हमने तो कितना हो गया? 10 to the power 4. 100/13 will be equal to 13 7s पहले ना, 7s, and then 6 after that we have just a number that is very near to 130. Then 7.69 I guess into 10 to the power 4. Can you write this down? Let me know when you're done. Let me just zoom a bit out. आपको सारा आंसर मिलता है. So here we have calculated the chi b. यहाँ पे we have plugged in its value. ठीक है? This is the final answer, and this will be in terms of atm क्योंकि यहाँ पे KH is having the same unit as that of pressure. The pressure is given at atm So KH will also be in ATM only. Done guys, yes or no? जल्दी लिख के बताइए.
Certain. So
What
can they
about
ask like a gram equivalence in the modes?
नहीं, generally they don't ask gram equivalence and all.
Okay.
इग्नोर करेंगे, ठीक है. We will do those things also.
Okay.
नॉर्मालिटी की बात कर रहे हैं ना आप.
Yeah.
अच्छा, there is one thing जो छूट गया बिल्कुल ध्यान से. Write a topic that is graph for Henry's law. ठीक है. So you can have graph only if you have a expression, a formula, something. ठीक है. If you have some equation क्या है यहाँ पे Henry's law का? Pressure is equal to KH into phi b. Those who have maths and all, they can see that it is equal to y is equal to mx. Y is equal to mx का मतलब a graph that is passing through the origin, right? Yes or no? Graph
Yes.
that is passing through the origin. So we have a graph like this. It is passing through origin. And in the y-axis we have y में क्या है? Pressure है, partial pressure of the gas. And x में क्या है? We have the mole fraction. ठीक है. So this is the plot for Henry's law, and the slope of this line will give you the Henry's constant kh. ठीक है. चलिए इसको ही बना लीजिए ग्राफ फॉर Henry's law. Is everyone done? Yes or no? Alina, Hanifa, Dania, Hamza. हाँ guys. No, not done. Four are done. Dania?
Yes, sir, done.
Done? Okay, chalo. So we'll meet again on Saturday, okay? And on Saturday we'll be starting and